Hello again, welcome back to Mr. Algebra. For this video we're going to show how to factor in the form of ax squared plus bx plus c, and the key feature here is that a does not equal a positive 1, so our a is some other value other than 1. Here we have some steps, 4 simple steps, but all these steps depend on you knowing how to factor by grouping, so you need to learn how to factor by grouping to do this. Step 1 is pre-simplify by factoring out a GCF if possible. So if any of these numbers here have something all in common, you factor that out first. The next thing you can do is multiply the a and c terms. That's the first and last. That comes from your f and l of FOIL. Number 3, you're going to find the factors of a times, that should say times, a times c, which add up to the b term. So the factors of the a times c that add up to b. And then number 4, you're going to rewrite this trinomial, which is that one, by breaking the middle term, the b here, into two factors you found in step 3. So the two factors we found here, we're going to rewrite this as those two factors. And then we're going to just proceed by factoring by grouping. For our first example here, the first thing we want to do is check to see can we pre-simplify, and yes, these all have a 2 in common, so we're going to factor a 2 out. That makes this become a 3n squared plus 1n minus 10. Now this 2, I'm just going to leave it out to the side and bring it down at the end because it is part of the factoring process. So remember, this is a, this is b, and this is c. So we're going to do a times c, and we're going to create a little table here. So a times c gives us a negative 30. And we want to have a sum of positive 1 from the middle of the table here. So in this list, we're going to list all the factors of negative 30. However, first thing we'll notice here is this is a minus or negative, which means the two factors have opposite signs, and since the middle term is positive, the bigger the two factors have positive. I like to do the small one on the left and the big one on the right, so I'm going to make sure my left one is negative and my right one is positive. So the factors that make negative 30 are going to be negative 1, positive 30, negative 2, positive 15, negative 3, positive 10, negative 5, and positive 6. So which of these have a sum of positive 1? If we can see that it's negative 5 and positive 6. And all we're going to do is rewrite this as negative 5n plus 6n, because they have to have an n like this. Now I'm going to rewrite this with 4 terms. So bring the f down, which is this one, 3n squared. And I'm going to break this into the o and the I, like we did in the previous example. So I'm going to write my negative 5n plus 6n in there. So negative 5n plus 6n. If I combine these together, you see it still gives me a negative or a positive 1 here. So now bring down my negative 10 like this. So these two n pieces come down. This one gets broken into the two factors. And now all you got to do is factor by grouping. So if you don't know how to factor by grouping, you got to go learn how to do that first. So we're going to group the first two, group the second two, and the GCF of the first group appears to be an n. Factor that out and we get 3n minus 5. And the second group appears to have a GCF of positive 2, so factor out a positive 2 and we have a 3n minus 5. And at this point, since these two factors are the same, we bring that out in front as 3n minus 5, and when I factor these out of each, all that's left over for the second factor is n plus 2, the GCFs from the previous step. Now don't go ahead and say this is your answer, because remember we had a 2 out here, so we got to bring that 2 all the way down and put the 2 out here, and this becomes our fully factored form. For our next example here, we're going to try to pre-simplify. Well, 2, 3, and 35. Can't simplify anything out, but this is a, this is b, this is c, so I am going to create a table and do my a times c here. Well, 2 times negative 35 is negative 70, and I want to have a sum that adds up to a negative 3. I've got an opposite or negative sign here, which means the two factors are opposite signs. Since this one is negative in the middle, it means my bigger factor is negative, so I'm going to keep the negatives on the right-hand side. So we want to list the factors of negative 70. They are 1 and negative 70. That gives me a negative number. 2 and negative 35. Then I've got a 5 and a negative 14. And I can do a 7 and a negative 10. And which of these has a sum of negative 3? Well, clearly these. So I'm going to write that as 7n, because I have an n right here, minus 10n. And this right here is what I'm going to replace the b value with. So bring down the 2n squared, and I'm going to replace this with those two because they still make a negative 3n. So I'm going to write my plus 7n minus 10n, and then bring down my c term, negative 35. And now that we have 4 terms, we can actually continue to solve by factoring by grouping. So we're going to group these two, find the GCF of the first group. Appears to be just an n, so we have 2n plus 7. And the second group appears to have not just a 5, but a negative 5, because I want the pattern to be plus plus. This is negative negative, so I'm going to factor out a negative 5. And that leaves me with a positive 2n plus 7. And you can see these two pieces are the same. These two factors are the same, so that's our first factor, 2n plus 7. And what's left over is the GCF that we took out, which is the n minus 5, and that's our other factor. Now, since I didn't pre-simplify up here, I don't need to bring anything else down, so this is my fully factored form. For our next example, we actually threw an equation in here, so this whole thing equals 99. We're building up to actually solving these, but in order for this factoring to work, all the numbers need to be pushed to one side and the whole equation needs to be equal to 0. So the first thing I'm going to do is rewrite this to 6n squared minus 15n, bring the 99 over as minus 99 equals 0. So factoring only really works when you have a 0 over here. I want to see if I can pre-simplify. 6, 15, and 99 appears to have a 3 in common, so if I'm going to factor out a 3, this will become a 2n squared minus 5n minus 33. Okay, so this 3, I'm going to bring it down at the very end. So I'm going to identify my a, my b, and my c values. And then over in the table, I have a times c. Well, 2 times negative 33 is negative 66. And they have to have a sum of the middle term, which is b, negative 5. So again, this is a negative, meaning the two signs are different. This one is a negative, meaning the bigger of the two signs is negative. So my bigger factor is negative again, so it would be like 1 in negative 66. So my bigger factor has to be negative to have a sum of negative. I'm just going to list the rest of the factors. Those would be 2 in negative 33, 3 in negative 22, and let's see, 6 in negative 11 also goes in. So which of these adds up to negative 5? Apparently this one does right here. So we're using the variable n, so I'm going to go 6n minus 11n. And this right here is what I'm going to use to substitute and replace the middle term with. Bring your a down, 2n squared, and substitute this with the 6n minus 11n. So plus 6n minus 11n. And then bring down the c term of negative 33. This 3, just can't forget to bring that down at the very end. Now continue to solve or factor by grouping. So group the first two. This first group appears to have a 2n in common, so I factor that out and I get n plus 3. This one appears to have an 11 in common, but they also have a negative, so I'm going to factor out a negative 11, and that will give me an n plus 3. And once we see that these two factors are the same, we know we did it right. Now we bring it down as n plus 3, and the other binomial factor comes from the GCS we factored out of 2n minus 11. And then the last step is bring that 3 we took out at the very beginning, because if I don't bring the 3 down, this will not make the original problem back again. So this becomes our final solution.